I'm going to try to expand a bit on the previous subject then. I intend to talk a little bit about libcurl and a bunch of SSL libraries and one SSH library. This is me. I hack on free software, mostly network related. I maintain kernel, libcurl, and libssh2 and CARES and a few things.
Speak louder.
Okay. And I work with embedded systems during the day as a consultant, and I work for hacks. But this is what I intend to try to cover. I work with libcurl then primarily. That's possibly the project I spend the most time and effort in. I deal a lot with the TLS SSL libraries in that project, and I'm going to try to touch the subject on why so many libraries and how they differ, why you pick one of them or why you don't pick a few of them, and how the situation is with SSH libraries and why they are so few. So, if you have questions, try to. I'm all willing to get interrupted and answer questions along the way. I think this is a pretty wide scope, so of course I won't be able to cover everything. So if you have anything in particular, I'll leave out. So ask. I started curl back in actually before 1998, but I called it curl 1998, the first release, and I made a library out of what curl did in the year 2000. So and the curl speaks a few protocols these days. I think there are 19 if you count them like that. It's a pretty widely used library. We have bindings for just about all languages I know, and even a few more. It's MIT licensed, or MIT X licensed. It's very liberal. When we did, or rather when I started curl, we of course immediately wanted HTTPS support. And back in those days, SSL was the only existing library. So back in those days, we started supporting HTTPS already since day one, or rather, I think summertime 1998. Powered by SSL. How do they pronounce that? This is. I don't know. That project turned into OpenSSL, as everyone knows, and we've been supporting SSL powered by OpenSSL since then. And of course, time moves on and code grows, and you get a lot more features, and you get a lot more contributors, and of course, GnuTLS grew and became really good at some point, and of course, the contributors made code so that we could do HTTPS with GnuTLS instead of OpenSSL, let's build like that. And then, of course, we supported more of these protocols up on the line, like FTP, SSL, and later on, there's a lot of more protocols using SSL. And then, of course, we have these other new contenders that are relatively new, at least SSL, and they have this rather convenient, very OpenSSL-like API. So it was very easy to get SSL to build. And then I think primarily because of Fedora, the Fedora project they have decided to switch everything over to NSS from whatever they used before, and that is usually turning code from OpenSSL to NSS. So we support NSS too then since 2007. And since libcurl is fairly portable, it runs on just about every operating system you can imagine. So if you want to run on the OS 400 and you want SSL, of course you want the QSSL support added in 2007. And then a few later, newcomers in the game, like the Polar SSL. It's a pretty new library. It has been popular recently, and of course, even more recently in our project at least, the AXTLS library. So as you can see, there are a lot of SSL libraries, right? So why 7 SSL libraries? And I bet there are more than 7. We support 7 libraries right now. I bet we can find more if we just like someone. And looking at these libraries, they all have a fairly different feature set and fairly different focus and ideas on what they should provide. And they all have different licensing ideas and development ways. And I'll try to compare these a bit to entertain you and give you an idea how it looks. I do want to stress that I'm not involved actually in any of these SSL library developments, and I'm a developer who use this. I use these libraries from client side. I'm aware that a few of these libraries have representatives in here and may have other ideas about these things than what I'll present here, but that's of course that's natural. And of course I'm willing to learn and reevaluate my position. OpenSSL is kind of I would say the most used, most popular SSL library in existence, at least as free and open source. It's very established. It has a lot of features. It has a very there's a lot of debate regarding the license, because the license is not GPL compatible, so everything that is GPL has problems with OpenSSL in one way or another. Lots of GPL projects, they just hide for the problem. A lot of people have some kind of exception to the GPL only for the purpose of OpenSSL. Well, it's a mess. It has a really quirky API. I believe it is mostly because it was made, OpenSSL is kind of the same API as they had back in SSL back in 1998, and they haven't really made anything about it since. It's not easy to program OpenSSL, and the documentation is really And a funny thing about OpenSSL in the context of all these other guys is that they are pretty much the only library who leaves out the common name and the subject alt name verification from the library, so each application has to do this by themselves. And very recently we saw how that impacted the entire software industry when this common groupthink bug in the common name code appears. And suddenly you realize that there are 10,000 applications with the same error that everyone more or less copy and pasted from everyone else. So everyone had to adjust that error instead of the single spot within the SSL library, as all the other libraries had the same bug pretty much, but they could fix it at one spot. And OpenSSL of course is big. If you're doing a small embedded system or whatever, you may think that OpenSSL is a few megabytes too big. GnuTLS, in my timeline, of course, it came after OpenSSL because we supported this like 7 years ago. It's primarily used because it's quite a different license than OpenSSL. This is LGPL, so it's very friendly to GPL, the family of licenses. And it has a big, sorry, it's a very good documentation. And it's very, I think, a consistent API. So it's a lot easier to get into writing a client doing SSL with GnuTLS than a lot of the other actually. When I started to prepare for my little talk here, I asked around about guys, what do you say about comparing SSL libraries? We support 7 of them. What's your opinion about pro and cons of libraries? And I got some very strong emotions against GnuTLS actually. And that was mostly based on that it's using libcurl as default. I know they support others these days, but libcurl, obviously, I haven't really researched this, but they have problems with running as different user IDs or whatever. There's a lot of bug reports in Ubuntu and all over about exactly that. NSS then, it's a library, of course, as everyone knows, it comes from Mozilla and Firefox and Thunderbird or whatever, I don't know exactly who used it first, but it's derived from there, so it's a Mozilla project. They have a completely different idea about how to get certificates and stuff. They have this database-oriented look on the world. So for us who have originated as OpenSSL users, we tend to look at certificates and stuff as files, PEM files on your disk reloading. But you don't do that with NSS. They don't even support loading PEM files from disk. Which is very quirky when you do the transition. In the Fedora project, of course, they solved that by doing a find patch that actually can load PEM files from disk. But the NSS project have accepted that after 4 years. It's very Firefox and Mozilla focused. It's so focused on only those projects. I mean, it's not that it isn't used. As I said, Fedora is changing to use this all over. So there are many projects using NSS now, but the developers and the mindset in this project is very much focused on Firefox and Thunderbird, to the extent that if you're suggesting new features and ideas, a lot of resistance will appear that, well, Firefox and Thunderbird, they don't use this. What do you need SRP for? We have no interface for SRP. Even though there are, I mean, potentially hundreds of applications out there who could use it. What is SRP? SRP is a TLS authentication protocol.
Is NSS still active with the lot? Is it very active?
Yes, NSS is very active. Yeah, they're a big project and they move along like all of the other big ones.
Well, it's not only Firefox focused, but also on some servers, because it had history with Netscape servers and Oracle and Red Hat, and are still using it in their server products, in legacy, in older products, and also, for example, Google Chrome uses it too.
Yes, I know a lot of other users, but the impression I get when I communicate and I read stuff on their site, the impression I get is that they are very focused on these projects.
Yeah.
And just look at their website, where is it? It's like multiple slashes under Mozilla //NSS, and the entire left column on their side this has nothing to do about NSS. There are links all over their site. It's actually another reason why the documentation is hard to get to on NSS, because it's hard to navigate on their site. And also they have this OpenSSL sees that they have a lot of functions that don't have documentation at all. I mentioned QSSL before, so that's why it becomes 7, but it's actually not very interesting to most people, because if you run OS 400 on an AS 400, it's interesting, but if you don't, it's not interesting. And I don't. GnuSSL is, we've used it in our project they have a OpenSSL API, and that's very handy because it's very easy to move code that uses OpenSSL to use SSL instead. It's very fast to just support it to use that instead. It has a GPL license, so it's friendly to GPL projects. The problem I've had with it is that, yes, it emulates the OpenSSL API, but it doesn't quite work as the OpenSSL API. So I've had problems with actually getting it to work exactly like OpenSSL. I've had, and also therefore you kind of end up in the weird OpenSSL problem then, because OpenSSL is not very good documented. So when someone emulates that API, you kind of inherit the problem with the documentation. There's also, this is a project without the huge developer community and awareness. I mean, you can find a lot of people discussing GnuSSL or developing online. Polar SSL is in many aspects, from a user's point of view, very similar to GnuSSL. This is another, I should mention that about GnuSSL, it's focused more on embedded systems because it's smaller. And Polar SSL basically seems to have the same idea. It's focused on embedded systems. They have a dual license system where you can download the GPL version and use it, and you can buy the commercial licensed version for whatever purpose you want. And Polar SSL is not very much used. I think it's getting more popular. So I see more and more projects like OpenLDAP and others who embrace this very much. But I don't think we've had that long track record to actually tell how it will run. And then we come to AXTLS. This is the newest one in the family. This has been around for a while. This is developed by one guy, and he's been doing it for, I think, 5 years. It's by far the smallest library. It only does TLS, and it's not very good documented, and it has had a lot of problems all the way since I even started trying to get it to work. Now it works. It's seemingly very good, and but it's not widely tested, and it's certainly not any big community or anything around it. When I asked him about the comparison about some of the other libraries, I shouldn't quote him, but he said something about that he would cry if any of the other libraries were bigger, or smaller than his. So if you can always then feature for feature what is important in an SSL library for you if you want to use it in a project. Is it important that you're GPL compatible, or is it on the contrary important that you're not GPL licensed? There are of course different use cases for different teams. There are things, specific features like, do you need TLS SRP? And that's basically just GnuTLS, I think, that supports it. Do you need TLS 1.2? Or on the opposite, do you need anything else? And the SSL v2, an old and an extinct thing, but some people still use it. You need it. In the back again to the Fedora project, who picked NSS for everything. They picked NSS for a reason, and that's because NSS is licensed, registered, or whatever it is they do with this FIPS 140. It's a kind of a US certificate for doing business with the government or whatever it is. So if that's important, yeah, you need a library that's FIPS 140 certified. And then of course there's the ones with embedded focus. If you need a small library, you need to get rid of some of the big ones. And if you need to run on Windows, of course, that might also be an issue to consider, because I don't think it will run on Windows. So, okay, how do we support them? It's not really that hard. I mean, to explain or to understand. How do you, as an open source project, support a lot of different versions? Yeah, we have an internal API, of course. All our libraries implement these functions. And if all libraries just provide these functions, And when we set up, create a connection with SSL, they just create the functions to deal with sockets, like reading or writing. I'm moving ahead a little fast now because I'm going to run out of time. So, yeah, it's really not that hard to actually write a code that supports 7 libraries. The hard part, of course, starts with how do you maintain that it actually continues to work in the long run. And that's a problem, of course, that all the open source projects get with whatever they do. And in curl, we have a ridiculous amount of build options. So we have this problem all the time. So just adding another library doesn't really matter to us. It just gets so we try to do test cases, and we do this constant distributed testing. So we have a lot of volunteers running various weird operating systems, and we have a test script, and then just updates from Git, run a lot of builds, submits back the results, non-stop doing that. And of course, it doesn't cover everything, but it's a start, and we of course we always depend on volunteers to set up machines and do tests and stuff. So, SSH libraries are quite not the same, and then I'm just based on the amount of libraries that exist for SSL and the maturity in SSL libraries. As I said, they existed back in 1996 or whatever, 95 when they started. For low-level C implementations, there are really only 2 SSH libraries, and none of them, libSSH and libSSH2, none of them are very mature or have existed for very long. And in comparison, they're very rare. They're not used at all as much. Possibly then because SSH is a much less used protocol, as ours mentioned before. We picked libSSH2 to base our support because we support SCP and FTP in libcurl. And we picked it basically on 2 factors. We wanted a license that was not GPL or LGPL, and we wanted the non-blocking operations. Right, and we want the APA side. And this kind of it's become a kind of a tradition among all the SSL libraries that the application does the actual connect, handle the socket, and then tells the library about the socket, and then the library then handle it. So that was also an important factor for us too, when we picked the library, that we wanted that kind of mindset. There are a lot of SSL libraries. There aren't that many SSL libraries. And that's a lot of work. It's always a lot of work. And that's a little web page I tried to start to actually compare SSL libraries from a client side, from my point of view, but I hope to get more feedback on this one over time. Of course, comparing stuff is always a bit hard, and you get not just objective comparison, you have to actually some own personal opinion too. Well, that's about it for me.
I have a question. Have you considered kind of exporting the core SSL library as an Uber SSL library application writers could use, so that they could actually switch the actual SSL implementations? Or is it like a separate library, or it's an internal library, or?
And now, yeah, I've considered it, but no, it's not an internal library. I just have an internal API, so all my code internally uses the same fixed API. But my API is very limited and focused only on the functionality that my library needs internally. So, and I know exactly, since I maintain like 3 libraries already, I know the pains. If I was going to release this as a library to work, it would be a lot of work. And maintaining a library is tiresome and energy consuming, and it's enough already.
One more question.
For what it's worth, glib is starting to do that, to abstract API, and have it so that multiple SSL libraries can be used through it. My question was, do you feel that what you've gained out of supporting so many SSL libraries is better than just sort of sticking to one? Is that something a lot of people should do?
Excellent question, but I haven't really thought about it, because in my world it's about all the users who want different things, and either you just say no, you can have it, or you say, well, if you bring the code, we can do it. And in my case, it's much more often the latter one. So I say, yeah, if you do the code, if you actually provide the entire port, then sure, we can support it. But of course, it gets more work. But I think the upside is that you actually find more. You actually fix the code better if more people use it, even if they use it with different backends. And usually also you can debug stuff better since you can switch backends, and you see, does the bug still exist when if you switch backend or not. Then you actually know if it's the backend's fault or if it's my fault or whatever.
Okay. Time's up. Thank you.